In this video, we're going to learn how to find a missing angle in a right triangle using trig functions, and more specifically an inverse trig function in order to solve for the missing angle. Remember, we have SOHCAHTOA to help us remember what ratios go with what trig function. Sine is opposite hypotenuse, cosine is adjacent over hypotenuse, and tangent opposite over adjacent. I forgot to say sine is opposite over hypotenuse. First letter goes on the numerator, the second letter goes in the denominator. Look at number 3 where it says find theta. Theta is a Greek letter for angles, just like x for equations. Find theta. So we need to find that angle. The right angle is right here. And just like with finding missing side lengths, we're going to label the side lengths first and determine what trig function to use. So 15 is going to be opposite. 19 is going to be your hypotenuse because it's opposite the right angle. And our adjacent side length over here is blank, so we're not going to worry about using it in a trig function. So I have opposite hypotenuse, O and H. That goes with the S, which stands for sine. It's going to be sine of theta is equivalent to 15 over 19, opposite over hypotenuse. Now, students usually guess at this point, as if I were to ask the question, how do you get rid of the sine so you get theta by itself? Sometimes they say divide by sine, or sometimes they say subtract sine from both sides. That only works when those inverse functions exist. So if I'm dividing both sides by something, that means I have to have multiplication present. If I'm subtracting something from both sides, I need to have addition present. I don't have addition or multiplication in this problem. I have sine of theta. So I need to take the inverse sine of both sides. And taking the inverse sine kind of cancels out like a square and a square root would to get theta just by itself. So the sine and the sine inverse sine, and the sine, it's like multiplying by 2 and dividing by 2. These two cancel out. And you're left with theta is equivalent to inverse sine of 15 over 19. To actually do inverse sine, you're going to press the second button on your calculators, usually blue, and a sign below -1 will pop up, and that'll be inverse sine. So theta in this case is going to be inverse sine of 15 over 19, which is approximately 52.14 degrees. And that's your angle that you're missing. So it's a very simple set up the equation, then do the one-step solving, which is just take inverse sine on both sides, or the inverse trig, more generally speaking, on both sides, and then you get theta by itself, calculate, and you get an angle that you were missing at the beginning of the problem that you now have at the end. Let's do one more example of finding a missing angle. That is your missing angle theta. Your right angle is right here. So that makes 35 your opposite side length. That makes 23 your adjacent side length, and that makes the blank side length hypotenuse. So therefore we're not going to use it. But we do have opposite and adjacent, and O and A go with T, which is tangent. So tangent of theta is equivalent to 35 over 23. So we want to solve for the theta. So we're going to do inverse tangent on both sides. And that way the inverse tangent sort of cancel out, and you're left with theta. And calculating inverse tangent, I guess, again, you're going to press the second button and type in the fraction inside the parentheses. So tangent inverse of 35 divided by 23. is going to be 56.69 degrees. Again, there's a one-step solving equation to inverse tangent on both sides to find your missing angle. So just to recap, first thing you do, label the side lengths, then determine what trig function you're going to use. In this case it was tangent. Write the equation, do the inverse trig function on both sides, and calculate to find your missing angle.